It's question show time. Your questions, my answers. As always, wherever you are, across my channel, question pops in your brain. Just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. Wilhelmo de Occidento. I fail to see the importance beyond minor curiosity of whether or not life exists somewhere else in the universe where we have no chance of interacting with it. The question has zero impact on my life beyond minor curiosity. Now, I know you're a big space fan, Wilhelmo, so I feel like you're probably like a little more curious. Like, imagine I could hand you an envelope, and inside that envelope was the answer to the question, is there life in the universe? Is Earth the only place in the entire universe, or is there life somewhere else? Would you open the envelope? Would you like to know the answer? That's the curiosity. And of course, we want to know the answer. We want to know if we're alone, or life is everywhere. And if it's everywhere, what kind of life is it? Is it similar to us? Is it totally different than us? These are the kinds of questions that we just don't have the answers to, and we really want them answered. So practically speaking, though, what would be the benefit of us, for example, receiving a signal from some kind of alien intelligence? Well, if they're a benign alien intelligence, if they're nice, then they might be transmitting useful information out into space that we could use. Like maybe they can be transmitting basic physics, information, engineering, chemistry, things that we could actually practically understand and be able to put into use. And this idea has been covered in science fiction quite a bit. So I think that if we could receive a signal, maybe there'd be something useful. Of course, there's kind of a dark side to that too, where they could be sending out a signal that is actually like an evil computer program, and if we build it, then we will unleash artificial intelligence, some kind of evil AI here on Earth. So you can imagine that could go the other way as well. And of course, if they're malevolent, then we would know that they're there and that they are potentially on their way to Earth, although it hasn't really happened in hundreds of millions of years, so the chances of it happening during our lifetime is fairly low, even though that's an idea that science fiction loves to talk about. But if they're relatively close, if they're within dozens, hundreds of light years, then we could theoretically start to set up communication with them. Obviously, it's going to take a while for the messages to go back and forth, but it's not never. And so we could package together a lot of really useful information and start sending it off to this other civilization. They could start sending really useful information back to us. And over hundreds of years, thousands of years, our two civilizations could benefit from being able to communicate with each other. So I think there are practical reasons why we'd want to be able to find out if there's life in the universe. But curiosity is reason enough. What else do we need? I want to know the answer to this question. Simba. Hey Fraser, here's one for question show time. How long did Mars' dynamo and magnetic field take to shut down? If you were alive on it at the time, would you have noticed this was happening? One of the best things about the Earth is the magnetosphere. This is, of course, this giant field of magnetism that protects us down here on Earth from the radiation coming from space. And Mars is cold and dead today, but it's thought in the ancient past it also had a magnetosphere. Astronomers think that it shut down about 4.3 to 4.2 billion years ago. So a long time ago. And when you think about how the solar system itself only formed about 4.5 billion years, Mars only had a global magnetic field for a few hundred million years until it had cooled down and its internal dynamo just shut down. And there's pretty conclusive evidence about 3.9 billion years ago of vast lava fields that have no imprint of the global magnetosphere. But how long did it take? How cool is Mars today? This is one of the big questions, and this is one of the big reasons why NASA sent the Mars InSight mission to the Red Planet, to actually put a temperature probe into Mars and to measure how the temperature is leaking out of the center of the planet. And as you probably know, unfortunately, InSight has been trying to hammer this temperature probe into the Martian regolith, and it keeps kind of bouncing around. And then finally they were able to put the shovel on top of the probe. They were able to get the probe below the regolith, so they couldn't see the probe anymore, but it still looks like it's bouncing around and not actually able to dig in and go down. And it needs to get down several meters before it can start to really properly measure the temperature of Mars. So the question that you're asking really is one of the most important questions about Mars, and we just don't know the answer, and we probably won't know the answer until InSight can deploy that temperature probe and we can find out what's happening to the temperature inside Mars. So stay tuned and hope that the InSight team can get the probe to work. Victor Gallagher. I was wondering, could those old lunar rovers be made operational again? I know that some people would want to preserve them for history, but they're still tools and should be used if they can be done practically. Yeah, so once the Apollo astronauts left the moon, they left their lunar rovers just on the surface of the moon. They used up the batteries. So if you just like showed up to the lunar rovers and hopped in, you wouldn't be able to drive them anymore. If you could recharge the batteries, it probably wouldn't work because the batteries have been sitting out on the surface of the moon. The temperatures are getting hot and cold and hot and cold, and it's probably killed the batteries dead. So if you brought new batteries, then you could probably get the electrical system working again. But they have been sitting on the surface of the moon for 50 years. They've been going through 100 plus degrees Celsius during the day, 100 minus Celsius during the night, back and forth and back and forth. And all the metals have been expanding and contracting differently. And so you can imagine there's a lot of wear and tear on all of the parts, the wheels, all of the surfaces across the rovers. So if you brought a lot of spare parts, maybe you could get them working again. Now, of course, they're not in the places where the next generation of lunar explorers want to go. They want to go to the southern pole. This is, of course, where there seem to be large deposits of frozen water ice. And so it makes more sense to go there and not to return to the landing sites that you've already been to. But I'm sure at some point in the distant future, when there's much more presence on the moon, I can imagine someone attempting to get one of the rovers going again. It's kind of a cool project. C. Argyle. If a star was ejected from a galaxy, would it take all its planets with it? If the solar system remained intact, is there any disadvantage to life outside of a galaxy? So you have to imagine the kinds of scenarios that would cause a star to be ejected from a galaxy. It's a fairly violent affair. I mean, one possibility is the star gets really close to the supermassive black hole at the center of the galaxy, and then it goes through some kind of three-body interaction. It gets kicked out of the galaxy. And of course, as it's just going right past the supermassive black hole, it's experiencing tremendous forces. The planets might get torn away, thrown off into space in their own directions, or go into the black hole. So that would be bad. Maybe you have a star that's in some kind of binary system with another star, and the one star goes off as a supernova and totally like slingshots the star out of the galaxy. And once again, that would be pretty bad. It would probably destroy, vaporize the planets if you're within a few light years of the supernova going off. So that would be rough. I think the only feasible way that you're going to get a star to gently leave a galaxy is if some intelligent civilization is actually pushing it. There's this idea of a Shkadov thruster, like a star thruster, where you can put a mirror on one side of a star and use the gravity of the star and the light pressure of the star to pull it around. And then, yeah, as you're slowly moving the star faster and faster away from the galaxy, you would assume the planets are going to come with it, because you could move, say, 10% the distance of the entire galaxy over the course of 1 billion years. So the acceleration forces are very slow, and that would bring the planets with it. But for the kinds of events that will kick stars out of galaxies, I can't imagine the planets surviving that very nicely. You wouldn't want to live there when whatever happened, happened. Horth SMS. Question for you. If both the US and China launch a mission to Mars on or about the same day, will the leading mission, one launched first, interfere with the trailing mission, the one launched second? How many hours wide is the window of opportunity in which both missions must launch? Space is really big, so there's plenty of room to launch hundreds of missions at a time, and within a couple of days, no problem. And they're not going to really bump into each other unless you intentionally aim them at each other. They're not going to cause some kind of vapor trail that's going to cause the other spacecraft any kind of problem. So, and again, a mission to Mars, one mission could land on Mars, and then a day later, an hour later, another mission could land on Mars, no problem. The only issue that you might have is if you're going to the moon. It's believed that when a rocket lands on the moon, it's going to kick up a bunch of this dust that's on the surface of the moon. And so you can imagine all of this regolith kind of forming this cloud around the moon. And so the next spacecraft that's orbiting around the moon and is going many kilometers per second is going to be impacted by all this debris, and it could cause damage. So you would want to space when missions are landing on the moon until you have a proper landing pad that isn't going to kick up regolith. But for going to Mars, no, there's no problem. Harlock MBB. Hey Fraser, some space probe missions take over 10 years to reach a planet. That's way too much time. What would it take to shave the journey duration? We can, for example, put the probe and a mini rocket in orbit and assemble them together. So there are a bunch of issues that define how long it's going to take a mission to get to another planet. And again, you know, you got to play Kerbal Space Program. You got to think in orbits. Think in circles, man. And so you don't just like point your rocket at the destination that you want to go, fire your engines, and you just go there. You're going on these great big ellipses. You're going on circles around the sun. And so Earth is on one circle, and if you want to get to Saturn, that's on a much bigger circle. And you've got to go follow a elliptical path that takes you, that intersects the orbits of both Earth and Saturn. And so you're spending a lot of time, which looks like, even though you are actually going towards Saturn, you're spending a lot of time on this big long curve that's bringing your orbit up to the orbit of Saturn. Now, if you just want to do a flyby, then you can go really fast. You can go as fast as possible. Take the tiniest probe, put it on the biggest rocket, fire it as fast as you can, and maybe you're going tens of kilometers per second as you zip past Saturn or Jupiter or whatever you want to do. And of course, we know like flybys are fine the first time. We had a flyby of Pluto. That was fine. It was great. New Horizons. But what we really want is we want orbiters. And if you want to have an orbiter, then you've got to be able to slow down when you arrive at your destination, which means you've got to take a more gentle trajectory. Or you got to have a really powerful rocket so you can turn your ship around and then fire your rockets again to slow yourself when you're arriving at your destination. So there are some other tricks that you can use to get faster to your destination. You can use slingshots. So you can use, say, the gravity of Jupiter or the gravity of Saturn to make your spaceship go faster. You can even use some of the inner planets. You use Venus, Earth, Mercury to do gravitational slingshots as well. And so when mission planners are trying to figure out how long it's going to take for them to go, they've got a certain budget that they can use. Do they have a few $100 million? If so, they're going to have to use a smaller rocket. They're going to have to take a longer path. They're going to have to incorporate a whole bunch of slingshots to finally reach their destination. Have they got lots of money? Have they got billions and billions of dollars? Can they afford a Falcon Heavy? Could they afford an SLS? Now you can go on a more direct path. You don't have to use all of those slingshots to be able to get to your destination. And you're right, in some future we can imagine refueling, where your various parts of your spaceship launch, they get refueled in space, and then they're able to, you know, they didn't have to use up a bunch of their fuel just getting into orbit, and then they can make a direct path to there. So we're still working this out. We're still waiting as rocket prices come down and down and down year after year, and we might see much quicker trips to some of the outer planets as these more powerful rocket systems, more reusable rocket systems, refuelable rocket systems come online. But until then, you want to go to the outer solar system, you're looking at a decade or more just to get there. Mr. Villalobo, in this video, you said there's the possibility that dark matter is made up of a zillion tiny black holes. Just punch a hole in that theory, all pun intended. Isn't it true that the smaller a black hole is, the shorter a lifespan they have? Wouldn't they have been able to last the 13 billion years that the universe has been around? Yeah, so the idea of dark matter being black holes, they would have to be this kind of black hole called a primordial black hole. And these are the ones that were formed, theoretically, right after the Big Bang, when the entire universe was incredibly dense. And there would be almost like folds, over densities in space-time that were so dense that it would just be filled with little black holes. And then as the universe expanded, those black holes were free to roam around the universe. And you're right. The idea is that those primordial black holes would be evaporating thanks to Stephen Hawking's theories about black hole evaporation. And so over the 13 billion years that these things have been around, any black hole that's less than about 100 billion kilograms will have evaporated already. And just to give you sort of a sense, that's about a 300-meter sphere of water's mass. So it's a lot, but it's not a lot. And then all of the ones that are more massive than that would still be out there just roaming around in space. And astronomers have come up with lots of really clever ideas on how they might be able to detect these primordial black holes using things like microlensing, sort of watch the light of a whole bunch of stars and see if every now and then the light dims a little as a black hole passes in front, searching for some of these primordial black holes that could be in binary relationships with other stars. And if you could eventually find a black hole that is in some binary relationship with a smaller star and its mass is below the minimum mass that should be possible with the black hole, that might be evidence that you found a primordial black hole. I should probably do a video about just the different ways that we might detect primordial black holes. Anyway, great question. Mink C3. You said the escape velocity of the solar system is 42 kilometers per second. The Voyager 1 spacecraft is going a mere 17 kilometers per second. So shouldn't it be on its way back now? The escape velocity of the solar system is how much of a one-time kick of velocity you would need to be able to fly up and out of the solar system and never return. And the amount of that kick depends on how far away you are from the sun. So if you're right at the surface of the sun, you're going to need a kick that's more than 600 kilometers per second. If you're out by the orbit of Earth, it's that 42 kilometers per second. Now, if you are able to launch from the Earth and you're able to take advantage of the fact that the Earth is going around the sun at 30 kilometers per second, then you only need about another 12 plus kilometers to be able to actually escape the solar system. And so imagine the solar system is this great big hill that Voyager is climbing out of. And it's still going 17 kilometers per second, but it's going slower and slower and slower as it's getting farther and farther away from the sun. The sun is trying to pull it back down into the solar system. But the speed that it has means that it will never be able to pull it back into the solar system. So Voyager is just going to keep on going until eventually it escapes the pull of the solar system entirely and just goes into orbit around the Milky Way. Jason Collins. If on the way to the center of Jupiter with a futuristic probe where atmospheric pressures become liquid, is it possible to have life in this ocean? Can life live in such pressures? Jupiter is a really inhospitable place for life as we understand it. Once you go down really just a few hundred kilometers into Jupiter, the temperatures increase because you've got all this gas under pressure, under Jupiter's immense gravity. And so you need to have a life form that could exist on hydrogen and helium and be under incredible temperatures and pressures. So it doesn't seem that likely. It seems the only possible place where it might be, there might be life on Jupiter would be up in the cloud tops. But then you have another challenge as well, which is that Jupiter is made of hydrogen and helium. And so imagine you had some life form like a bacteria or whatever. It would have to be able to float persistently in gas up at the high parts of Jupiter's atmosphere that is lighter than hydrogen. And the only thing that's lighter than hydrogen is heated hydrogen. So you would have the situation where these tiny life forms, they could be held aloft in the clouds and they could be buffeted around and floating around in Jupiter, but they might go too low and then they'll get cooked, or they might go too high and get frozen as they get out into space. They might get hit by Jupiter's radiation if they go far enough away. So it would be pretty tricky for life as we understand it to exist on Jupiter. Better to look in Jupiter's icy moons, which seem like they're perfect for life as we know it. But you never know. Daniel Roig. Maybe that's what happened to our sun's binary partner. Now it's a grapefruit-sized black hole on the edge of our solar system. So we talked about this idea of a primordial black hole, right? These black holes left over from the formation of the universe. And they could be the kind of object that could be orbiting around the solar system, this Planet 9 primordial black hole. But if the sun did have a binary companion that exploded as a supernova and then became a black hole, then it would have had to have been a star that was dozens of times more massive than the sun. And now it would be still many, many times more massive than the sun. And so the sun would be orbiting this black hole. It would be obvious that we are orbiting a black hole. We'd just be going around and around some invisible mass. So if the sun had a binary companion, it got torn away from us a long time ago, and it definitely was not a star large enough to explode as a supernova and turn into a black hole. Grumman Pilot 99. Hey, isn't Fraser supposed to be on vacation? Glad he's responding to comments. Yeah, I'm not actually on vacation during the summer. We just stopped doing all of the live events. So we don't do open space, we don't do astronomy cast, we don't do the weekly space hangout, I don't do the premieres on YouTube. And that allows me to just more time to think deeply, to work on projects that I haven't had time to work on over the rest of the year, spend time with my family, but I'm still working harder. And hopefully when we come back in the fall, we'll have a lot of really great new ideas. We'll implement a lot of this stuff. Gives us a chance to catch our breath. So no, I'm still in the comments. I'm still putting out videos, still question shows. We're still working hard. All right, those were this week's questions. I hope you enjoyed them. I always love answering these questions. As always, if a question pops into your brain, write it down. I'll gather them up and I'll answer them here. And I'll see you next week.